All right, we are going to be looking at some of these rate questions, and particularly rates and extrema. So as we kind of break down each of these questions, they're going to be very similar. We'll probably make this actually one long video that goes with all three. But yeah, let's go ahead and take a look at it. It says a person sets up a saving account 11 years before their retirement. And we have a function here, a of t equals 2t e to the sine t, that represents the amount of money in the account, and where we have that interval 0 to 11. Part A says find a prime of 4. Well, with Desmos, this is actually crazy easy. What I'm going to do is type in a of x. I'm going to use x instead of t. And that makes it a lot easier to do a derivative. You could type t, but it makes it easier if we just substitute an x for the t. And then the rest of the equation, 2x e to the sine x. And we want our window to go from about 0 to 11. So I'm going to change my window. I'm going to say -1 to let's say 12, so it's about the same amount. But I do notice that it's a little bit higher. So let's make our y values go maybe from 0 to, I don't know, 20. Is that enough? Let's see. Still not enough. Okay, so let's go a little bit further. From 0 to, let's say, 30. Still not enough. Keep going. All right, 0 to 40. I think this should be enough. Oh my goodness. Oh no, that was the wrong thing. That was the label. We want this to be about, let's just say 50. 0 to 50. Okay, there we go. Now I can zoom out a little bit just by kind of scrolling or pinching depending on what kind of device I'm on. So I have an amount there. I'm also going to put in here a graphing kind of window. So I'm going to give myself a window just by typing the inequality. 0 less than equal to x less than equal to 11. So this is like the window that we're looking at, that shaded blue area. All right, it says to find a prime of 4. All I got to do is type a prime of 4. And that's what makes this so easy with Desmos if we do it with x instead of t, is that the derivative can be defined as just a prime. So a prime of 4 equals -1.5150. This means that the amount of money is decreasing at a rate of, let's see, this is thousands of dollars, -1.5150 thousands of dollars. I don't have to like try to convert it into a dollar symbol or anything else. I could just use the units like that. And it's per year. Okay. That's it for part A. Part B, find all times t for which the amount of money is decreasing. Okay, this money is going up and down, kind of when you invest into a retirement account. Sometimes it goes up and sometimes it goes down. Overall, it's supposed to go up over time. But that's part of the risk that we kind of take with that. So to graph the derivative, which would help me here, I'm just going to type a prime of x. And I'm going to turn off the original, the red graph. And now what I'm looking for is any time that I'm positive or a positive height or above the x-axis over this interval. Well, it appears to be true from 0 to this point, which is 2.07393. So we could say the amount of money, oh wait, it's not increasing, it's decreasing. So it'd be 2.07393 to 4.48767 is decreasing for 2.07393 less than t less than 4.48767. And it looks like there might be a second area, a second zone here. And that goes from 7.97963 to 10.90373. And 7.97963 less than t less than 10.90373. And our reason, we have to give a reason, because a prime of t is less than 0. We just have to say the derivative is less than 0, so the rate is decreasing. All right, now our third part here, where is the most amount of money over the 11-year period? All right, for this we have kind of a couple of things to consider. First, we got to say the candidates for the most money are the endpoints, and those are t equals 0, t equals 11, and a relative max. Let's see if we hit any relative max. Well, in this picture of the derivative, let's try and turn off these points here for a second. In the blue zone, a relative max is going to occur when we change from a positive to a negative. And that's going to happen here at 2.7393 and here at 7.97963. So that'll be at t equals 2.707393 and t equals 7.97963. All right, now here is the great thing about doing this in Desmos especially. I can make a table. So if I click the plus button and add a table, I can throw that in there. And instead of calling this x1, y1, I'm going to call this t and a of t. And then all I got to do is type in those t values that we have. So we have 0, we got 2.07393, we have 7.97963, press down again, and then we have 11. And it's very clear that the most amount of money would have been at t equals 97963. So the most money occurs at t equals 7.97963 and it is $43,041. And I'm going to just copy this table as well. So I'm going to put T, A of T here, because I did evaluate it with a calculator, but I got to kind of show my work somewhere. And at 0, it's 0. At 2.07393, it's 9.96091. And at 7.97963, it is 43,000.041. And at 11, it's back way down to only 8,000, 8.0934. Cool. And there we go. That's it for this this first question. The other ones are going to be very similar, and they'll get all stitched together into one video here. We'll zoom out so you can see all of that together as one answer. There we go.